Kia ora koutou. In this video lesson, we're going to be going over a normal distribution problem that you might find on your external on probability methods. All right, first patai. We are being asked to calculate the probability that a purchaser took between 98 and 112 minutes to assemble a bookshelf. Keeping in mind that we are told we have a mean of 98, we write that down, mean 98, and a standard deviation of 14 minutes. I'm writing that down as well, standard deviation 14. So between 98 and 112, my beginning x value is 98. My second one is 112. I have shaded in appropriately. And also thought it'd be a good idea to show when the mean is 98, that's right there in the middle. If the standard deviation is 14, when we add 14 to 98, that gives us 112, and that's plus 1 sigma, or 1 standard deviation above the mean. If we add another 14 onto the 112, we get 126, and that will be plus 2 sigma, or 2 standard deviations above the mean, and the third standard deviation, 150. And when we look at our table, looking up values, we can see that beyond the third standard deviation, it's practically a zero probability of there being any data there. So looking at the probability between 98 and 112, because 98 is the mean, it has a Z value of 0. And using our formula here, which is provided on your table, we convert the 112x value into a Z value, which is exactly 1. We look up the 1 in the table, and we see the probability of x being between 98 and 112 minutes is 0.3413. Next. Now, one habit I want you to get into is to every single time you're doing a patai, write down the mean, 98. Write down the standard deviation, 14. Those values will not change unless it is explicitly stated. Now, we want to know what's the probability a purchaser took less than 80 minutes. So there's my 80. It has to be to the left of the 98. So less than 80 minutes is shading to the left. Now, you'll notice that I put x1 as 40. Reason being, if 3 standard deviations below the mean was 56, minus 14, I get 42. So going more than 4 standard deviations below the mean, there's nothing down there. Anyway, converting the 80 into a Z value using the same formula from up here, which again will be given to you, the 80 has a value, a Z value of negative 1.286. You can see that right here. So I look that value, negative 1.286, in the table, or 1.286, because as we should recall, both sides of the curve are symmetrical. So the probability of being positive 1.286 standard deviations from the mean is the same as being negative. So I look up these values in the table, I get 0.4008, and that has to go starting at the 0. Looking at the shading, on the table, we can see that these values always go from 0 down to or up to the Z value. So that 0.4008 is here. To find out the probability of the shaded part, we subtract the 0.4008 from 0.5 to get 0.0992. And just as a reminder, reason why we did that, if I were to ask you how much data is below the mean, you would say 50%, which is 0.5, okay? Next one, calculate the probability a purchaser took between 90 and 110 minutes to assemble the bookshelf. Once again, first step, draw the curve between 90 and 110. So once again, the mean is still 98. Our sigma is still 14. My first x value is 90, and my second x value is 110. Converting those values into z's, we get those two values. Looking up in the table, I have the blue values written on the curve, and we add those together to get probability x between 90 and 110 of 0.5202. Last one. If 380 bookshelves were sold, how many purchasers would you expect to take more than 2 hours to assemble the bookshelf? Keep staying in this habit. Mean, 98. Standard deviation, 14. So more than 2 hours. Well, we're not going to say 2. 2 hours, and these are all minutes. That 2 hours is 120. So greater than 120 is what we're looking for. We change the 120 to a Z value. We get 1.571. That probability is 0.4419. Writing that in there, well, that's not the part I'm looking for. I'm looking for the shaded part. So once again, we subtract the value from 0.5 and we get the probability of being more than 2 hours, 0.0581. Now, since we were asked for an expected number, we take the probability times the number of bookshelves. The 0.0581 times 380 is 22.078. Therefore, we expect approximately 22 of the 380 bookshelves to take more than 2 hours. Any pad thai, please send them my way. If you liked what you saw, please consider giving it a like. Thanks for watching. Mauri mahi, mauri ora, ka kite ano.
Yonichi.